study about units and measurement. Measurement plays very important role in studying physics. As we all know that physics is the science which consists of theoretical as well as experimental studies. So to perform experiment as well as to do theoretical calculations, we need measurement. So let us study about measurement. There are many physical quantities which include in the measurement and study of physics. So they are categorized into two types. So physical quantity which is categorized as first is fundamental physical quantity. And second, it is derived physical quantity. Let us study one by one. Fundamental physical quantity are those physical quantity which does not depend upon any other physical quantity for its measurement. And derived physical quantity are those physical quantity which depend upon other physical quantities for its measurement. So let us study one by one in detail. There are total 7 fundamental physical quantities and there are many derived physical quantities. In addition with derived and fundamental, there are 2 more supplementary physical quantities. They are related with the angle. So first it is fundamental. First quantity, length. Unit used for the measurement of length, it is meter. Its symbol is small m. Mass, it's measured in kilogram. Kgs. Time, second. Temperature, it is measured in degree Kelvin. It's a name of scientist. Current, electric current. It is measured in ampere. This is also name of scientist. Amount of substance. That is measured in mole. Its symbol is small. And the last one, that is luminous intensity. It is measured in candela. and the symbol is CD. Why do we use symbols? The reason behind it is what? While solving many problems in physics, it is difficult to write these this much big words while solving the problems. So we use symbols for them, and it is throughout the physics, it is common for all. It doesn't change. Now what is this unit? In earlier time, there are many system of units which were used, but they were not common all over the world. There are different systems of units that is followed. To understand these systems of units, first of all, let us try to understand what is meant by unit. Unit is some physical quantity. Let us consider if we want to buy a sugar from shop, then how do we ask to shopkeeper that we want this much kilogram of sugar, right? So this kilogram is a standard which is used for the measurement of any mass, and that is common, that is same all over the world. So the standard which is used for the measurement of any physical quantity, that is called as unit. So unit is the standard which is used for the measurement of any physical quantity, and that is common everywhere in the world. There are many systems of units which were used previously. Let me introduce few of them, few of the systems of unit. MKS, where this M stands for, it is the unit for the measurement of length, meter. This is the unit used for the measurement of mass, kilogram, and this is the unit, S is the unit for the measurement of time, that is second. Another system of unit which were used in previous time, that is CGS. So CGS, again this C stands for mass, C stands for length, G stands for gram, S stands for second. So C centimeter, G gram, second, another system of unit, it was used FPS. So it is foot, P pound, and this S stands for second. Now looking at these three different system of units, we can make a conclusion that these three systems of unit, they were different in different countries. So it shouldn't be there, that will become comparison of results amongst the scientists. It will become difficult, or it's not easy to exchange the ideas, it's not easy to exchange the results amongst the scientists all over the world. So it was decided that in the 1971, the 14th International General Conference, it was decided that there has to be a common system of unit, and then universally accepted system of unit was taken into consideration, that is SI system of unit. It is called as System International D units or International System of units. So this is the international system of units which is common all over the world now. And just now we stated the units of physical quantities which are common everywhere in the world, and so exchange of ideas, exchange of results of different experiments which become easy due to this common system of units. Okay, now let us see some of the derived physical quantities and their units. Before that, let us see supplementary unit. Supplementary units, they are used for the measurement of angle. Plane angle. Plane angle, it is for two-dimensional geometry and generally used a symbol as d theta. Unit used for its measurement, it is radian. And in short form, it is written as rad. Another supplementary unit is solid angle. It is the angle measured in three-dimensional geometry. It is generally used a symbol d sigma, and unit used for its measurement is steradian, and short form is SR. So this is what the supplementary unit. Now let us study about derived unit and derived physical quantities. As I stated earlier, derived, its name itself implies that it is derived from some other physical quantity. That is, it depends upon some other physical quantity for its measurement. So, derived physical quantity. Let us see one by one. Force, its SI unit is Newton. Acceleration, its SI unit is meter per second square. Velocity, it is meter per second. Pressure, it is force upon time, so it is Newton per meter square. Power, it is work done upon time, so it is joule per second. Torque, it is force into perpendicular distance, so it is Newton into meter. Linear momentum, it is the product of mass into velocity, therefore it is kg meter per second. Few more we will see. Angular momentum, it is the product of moment of inertia I into angular velocity omega, so it is kg meter square per second. Moment of inertia, that is kg into meter square. energy, any kind of energy, kinetic, potential, anything. Energy, it is in joules. So these are few of the derived physical quantities which can be used for the measurement of, which can be used to express units of these physical quantity. Looking at these physical quantities, if I write formula for it, let me do it. Force, it is mass into acceleration. So measurement of it is dependent on mass and acceleration. Here acceleration, it is dependent on velocity and time. Velocity, it is dependent on displacement upon time. Pressure, it is force per unit area. Power is the work done per unit time. Torque is the force per unit area. Linear momentum, mass into velocity. Angular momentum, I into omega, that is moment of inertia into angular velocity. Moment of inertia, mass into square of the distance between the axis of rotation and the point at which force is to be applied. Energy, if we take kinetic energy, it will be half of mv square, or if we take potential energy, it will be mgh. Okay, so these are the quantities. Looking at it, its formula includes more than one quantities, therefore they are dependent on other physical quantities. Therefore, if the quantity for its measurement, if it is dependent on other physical quantity, then it is called as derived physical quantity. It is derived, it is calculated from some other physical quantities. Okay, so that's all for the introductory part of the units and measurement. Thank you.